So now let's talk about a new application scenario for this type of RAG application, which is code generation. So what we're going to do here is that we have a code generation with RAG and self-correction, inspired by the paper Alpha Coding. So what we're going to do here is we have a code generation with the context of the technical document, and we will check if that meets the requirement or not. If not, then we will self-reflection, and then use the context that we have it, and regenerate it again until we meet the final code solution. So we have here like a cell package, run this above, and we can copy and paste the instruct API key, and then once it's ready, then we can run the documents. So we already use recursive UI loaders to load the document from LangChain documentation, and we can basically concatenate this into a document so that we can retrieve that later. So once it's ready, then we can start doing the code generation. So we have a code generation prompts using chat prompt template. So we have a system prompt and a placeholder for a user prompt. And once it's ready, we can have a chat model. So we have data model. A data model is a data class that we can use to encapsulate the data for agentic RAG, or agentic application, or agentic RAG application. So we have LMs. And yeah, so what I'm going to do here is we have a chain of information, which is that we can use the code gen prompt along with M's with structural output together to invoke this change to build application like this. So we have a prompt that how do I build RAG chain in LCEL, and we will invoke code generation chain from OpenAI by using the code gen prompt and the LMs. Okay, so we can run this as well. And ready. Now it's an Anthropic one, so we will use Anthropic model to do pretty much the same thing, but the differences is that we're going to do here is we're going to check the output from cloud and also an errors that it has. So we have first output. So we have the question over here: how do I build RAG chain in CEL? And we have the same chain, but along with the output forcing and the error detection, and how to actually check the output of the RAG generation. Okay, once it's ready, then we'll run this as well. Oh, this one here, this one here. So now we have a agent, like a foundation ready, so we can build a state of the agent. Now we're going to do that later. So we have a graph state. So if you like graph, the state of graph for LMs. So what we're going to do here is we have errors, message, and generation and iteration. So we have errors that will be stored into the state of the graph. Message is a list of message, and a generation, which is the final outcome of the code generated. The iteration is number of iteration, which is integers. So we have maximum iteration is 3, and flag is do not reflect. So we're going to start generated. So what we're going to do here is a series of the nodes, and we can use this series of nodes, including code check, generate, and so forth that we built before into a node. So we have a workflow using LangGraph, and we will define the types of data using graph state that we talked about earlier. And we will add node, generate, check node, and reflect. So it's basically like a flag for the nodes. For example, here we have the function like reflect, and we'll name it using the string reflect. Once it's ready, you can start age from start to generate to check node and check the node. You'll see we need to have a conditional age, which is you can see over here. We have a conditional age to see whether we want to reflect or want to return the final solution. So what we can do here is that we gonna have a conditional age, and we have a age that connect reflection into the final generation. And we compile this graph together, and once it's ready, then we can run this above. Yeah, it's ready, so now we can start invoking the entire application using the question, how can I directly pass the string to Rumble and use it to construct the input native for my prompt. So we can run it, generating a code solution, and we can also see the final solution of the generation using the structure that we see earlier. Yeah, once it's ready, then we will pretty much done with this application. And the other one is like using the evaluation from LangSmith, but we will skip this part. So we're checking solution, fail, and then we will look at whether we need to regenerate or reflect it, and we have the final answers ready over here. Yeah, that's exactly how we can use code generation along with RAD Assistant. Thank you very much.